I want to give you another layer of learning about IP addresses. The internet is just a bunch of computer devices connected together. Well, in order to have a unique IP address, it needs to be registered. The Internet Assigned Number Authority, IANA, helps to coordinate the IP addressing system. Internet service providers and regular individuals would obtain their IP addresses from an internet registry under IANA depending on where they're from. The American Registry for Internet Numbers, ARIN, supplies the United States with their IP address. As you know, IP addresses range from 0.0.0.0 to 255.255.255.255. That's a lot of different IP address combinations, right?
Yeah!
The possibility is like 10 to the power of something, and that power of something is a lot. So they started to run out of possible number combinations.
Oh!
One solution to this issue was the Network Address Translation, NAT. With NATing, we were able to turn one globally unique IP address into many private IP addresses. Let me explain further. Global IP addresses, aka public IP, are IP addresses registered under IANA. Without a global IP address, your device will not be internet accessible. You can assign an unregistered IP address to your device all you want. The world would not know how to route to it because no one but you know and agree to that configuration. The following are private IP addresses. These IP ranges can never be registered to a person or an ISP. Everyone is free to use these IP address ranges all they want for their internal network, but only your home or business network router knows how to route to these devices. In order to route to the outside world, the private IP addresses are translated to a global IP address. One major type of NAT is called Port Address Translation. I know, a type of NAT is called PAT. Sounds weird, right? With PAT, a single global IP address is translated into many private IP addresses by using mapping tables based on the source and destination ports. In this picture example, let's say 10.10.10.1 wanted to go to facebook.com web server, which is on the internet. The request will hit the router will translate that traffic to its global IP of 63.63.63.1:8000 as the source address. In this example, 8000 is the source port number. When facebook.com replies, the packet will have the 63.63.63.1:8000 as its destination IP and port. When the router receives that reply, it remembers that traffic on port 8000 belongs to the internal IP address of 10.10.10.1 and sends the traffic to the appropriate recipient. So you see, one global IP address can provide internet access for up to 65,535 different traffic because there are 65,535 different ports associated to one IP address. So the PAT technology allows us to use less global IP addresses by duplicating private IP addresses all over the world. Although NAT has slowed down the rate of IP address use, it's not a permanent fix. There is still a shortage. The permanent solution was the invention of IPv6. Here's an example of IPv6. We'll never run out of IP combination with IPv6, right? Well, never say never. I'm sure that's what they thought when they came up with the IPv4 scheme. Essentially, IPv6 is a whole separate internet from IPv4. Most technologies can translate between the two versions, so folks using one or the other really can't tell the difference. The idea was we will run out of IPs and folks will use IPv6, but NAT made people less desperate for IPs, so that switch has been a very slow progression. IPv6 goes by internet rules slightly similar to IPv4, but there are some significant differences between the two aside from the obvious length difference. IPv6 uses letters and not just numbers like this. We won't go over IPv6 in this course, at least not yet. I think you're better off mastering IPv4 for now. Coincidentally, NATing turns out to give better security because it conceals your device true IP address from the internet. And if you can't find me, it will be harder for you to attack me. Let's see what else. Oh, there's also a type of NAT called static NAT. A one-to-one translation where one public IP is translated only to one private IP. Then there's dynamic NAT. In this one, the router has a pool of public IPs to select from. So as the private IP goes out, the router simply selects a public IP from the pool. And finally, there's the Nats in DC. You know, the baseball team. Just checking to see if you were paying attention. That's it for natting. Put that nugget in your back pocket. See you on the next one.